We are still on 11.5. The last time we did the ordinary annuity formula, and that was ugly enough. And you remember when we did it, we kind of did it in bits because something as messy as that requires a fair amount of being careful or you won't get it correctly. Well, if you think that one is bad, this is the sinking fund formula. And the sinking fund formula, oh, I'm getting an echo there. I will put these guys are from 11. Oh, these are 11.5. These are the questions that you use the sinking fund on. And you just hold on a second. I'll mute you also. I won't get echo. Don't know if you can hear the echo I'm hearing. And back to our guy. So essentially what you're going to use this formula for is how much money, M, do I need to put away typically a month so that after a certain amount of time, I will end up with capital A dollars. So you can imagine a situation where you want to find out how much monthly payments.
Does that formula, it says M equals A-I-N? The top one?
This top one says A brackets R divided by N, another bracket, all over, big fraction. In another bracket, 1 plus R over N, NT, take away 1. It's called the sinking fund formula. So if you ever see a phrase, sinking fund, you're probably going to be looking at this guy. So let's make up a story similar to one of the questions that we've got here. Right, in question 7, for instance, you're going to, you need $8,000. And the interest rate that you're getting is 0.5%. And that 0.5%, you're getting it annually, which means once a year, obviously. And the time is going to be for 6 years. And we're going to figure out how much, you put that together, how much that is going to be, in other words, find out what M is. So how much do you put away so that you'll end up with $8,000 in 6 years, right? At 0.5% interest, yikes, that's ridiculous. And doing it annually. Okay. So I'm now going to go over and show you how I would tackle this question. So hopefully you're seeing a big calculator and there's the question. You see, it's basically, they just give you the numbers. So
I don't see a calculator.
Yeah, no calculator.
Okay, it looks like you can only get one or other, but not both. Okay, can you now see a calculator?
Yes.
Okay, I was hoping you could see both at the same time, but evidently I was wrong. Now, the formula that I'm using, oh God darn it in space, I better write down the numbers before I start doing any button pressing. So, M is A brackets R over N all over this horrible guy. So really, if you know how to do awkward calculations, you just, it's a plug and chuck. So what's it going to go? It's going to be 8,000, right? Times 0.05. Yeah, 0.005, that's 0.5%, divided by 1, all over 1 plus 0.005 over 1 raised to the power of 1 times 8, take away 1. That thing there is what we need. So what I'm going to do is I'm going to break it into 2 chunks. I'm going to find 1, and then I'm going to find 2, and then the answer to 1, I'm then going to divide by 2. So it's like a 3-stage process. So I'm going to find out what 8,000 times 0.005 over 1 is. And I think I'll better do it over here because it's going to be a little bit easier to see. 8,000 times 0.005 divided by 1. And the answer I get is 40. So the top bit is 40. Now the bottom bit is 1 plus 0.005 over 1 times 8. And then you take away 1. Let's see what that looks like. Put it in a bracket. Go 1 plus 0.005 divided by 1. Close the brackets. To the power of 1 times 8, which is just 8. Then take away 1. And this guy comes out to be 0.040707. And that's guy number 2. So what I'm going to do now is take 1, the top answer, and divide it by 2, the bottom answer. And here's a little trick you can do. The top answer is 40 divided by, if you want the bottom answer, right here where my finger is pointing, right here, in blue, it says ans. So if you go blue button, that minus, it'll take that horrible decimal, and that way I don't even need to worry about missing it or retyping it or whatever. Boom. And the answer I'm going to get is about $982.63. So if you want to have 8,000 at the end of 6 years and the bank's giving you 0.5% interest and they're only giving you every year, right? So it's not that nice of them. You need to put away that amount of money, right? That's what you have to pay every single year, right? Once a year, you pay that amount of money. And by the end of that time period, you'll have collected $8,000. It's hardly worth it. Say again?
Was T8 because you used was T6 or was T8 because you used 8 in the equation?
Oh,
but you
then I will now change my question to suit my answer. It's now 8. Right. I was just a typo, but I misread one. So for an 8-year period, this is what you would do. So it's really a case of do the top bit first, do the bottom bit second, and then just divide the 2 answers using that little trick I showed you there. And that will get you by the fact that this is a really ugly calculation. So what I'm going to do now is make up our own story. We all want to be millionaires, don't we? Yes. Okay. So I want $1 million. Okay. Let's say that I get an interest rate of 5%. Let's say I'm going to pay in money monthly. So there's going to be 12 of them. And I'm going to do this for 30 years. How much do I need to pay per month for that 30-year period to end up with $1 million at the end of it, right? So that's kind of what we're calculating here, right? How much do I need to pay every month to end up with $1 million? So our formula, monthly payment, A R over N. 1 plus R over N in T, take away 1. Now that's going to be $1 million times 5%. Okay, I'm going to mute you again. I'm getting some noises. I'm so easily distracted. There we go. So where was I? I got 1,000,000, 0.05 over 12. That's where that came from. On the bottom, I guess I don't need these brackets because I'm doing it with a calculator. So it's 1 plus 5% divided by 12 raised to the power of 12 times 30. Take away 1. Okay, here goes. Clear this one out of the way. 1,000,000 times 0.05 divided by 12. So the top answer, which I'm just going to call 1 now so I don't have to write it all up, is 4166 point, lots of sixes, right? Now do the bottom answer. I just need to do this guy. Bracket. 1 plus 0.05 divided by 12, close the brackets, raised to the power. If you can do it in your head, you should, because it's just less buttons to press. 12 times 30 is 360, right? Take away 1. And the answer to 2 is 3.4677, a whole load of stuff, right? And so the answer to M is whatever 1 is divided by 2. And so I'm going to go 4166 point, lots of sixes, divided by, and instead of typing that in, blue button, oops, blue button minus enter. And you get kind of cool. Unless I've hit a wrong button there, that is a very reasonable amount. Okay, I know $1,000, $1,200 is a huge chunk of change, but it could have been a lot worse, couldn't it? Now, do you know if you only put $600, I bet you that would be $500,000. And if you put $120, I bet you that would be 100,000. So if I know the million, I can kind of factor the other choices in. Do you see how this ugly formula is going to work? How we're breaking it into smaller, more manageable chunks so we can do it in our calculator. Any questions about this one? Are we good?
Would you mind doing that one more time by chance?
What, the calculation part, or just do another one?
The calculation part.
Okay, here goes. The top guy is going to be 1,000,000 times
Okay.
0.05 over 12. So 1,000,000 times 0.05 divided by 12. And the answer you get is 4,166 and a lot of sixes after that. So that's what I'm calling number 1. The top is number 1. The one underneath it is going to be called number 2. And it's this calculation here that I'm about to do. So I'm going bracket 1 plus 0.05 divided by 12. So that bit. Close the brackets. Raise it to the power. 12 times 30, I'm just doing that in my head, it's 360. And then take away 1. And I still get 3.4667, so that's looking good. So 3.46 and some 7s, that's the bottom answer, right? That guy. Now, the one we want is top divided by bottom. The answer to 1 divided by the answer to 2. So I'm going to go 4166 point, a lot of 6A's, divided by, I could just type that in, but I'm just going to go blue button and this guy here. Blue button answer. Now, when I hit enter, $1,201.55. Are we good?
Yep, we're good.
Right. So I'm going to give you one because the best way to find out if you know how to do it is to do one. Can you see how you can't really not, you kind of need a TI-84 or at least a really good calculator to do this, right? So if you've got a decent calculator, that's fine. But you can need to invest in one or this homework's going to be a pain in the butt. It surely is. So since I'm going to do, I guess a make-up question, I can pick anything I like. I want $50,000. I'm really good, which I'm not, at the stock exchange. So I know I can get 10% interest. You know, a growth rate, 10%, not interest really. I'm going to do it monthly because that's pretty typical. And I'm going to do it for just 10 years. And I'm going to use a sinking fund formula. That way I know which one it is to find M. M is how much do you pay a month for that entire 10 years so that you'll end up with 50,000. So I like writing down this ugly formula. It helps to kind of, you know, get it stuck in your head, even if you don't need to memorize it, which you don't. I suggest strongly that you just write down on a card, sinking funds formula, write this down, and maybe an example would be very helpful as well. Since I'm using the calculator in 2 stages, I'm not going to put that extra bracket in. You probably see it in a lot of calculations, but I'm not bothered because I know I don't need it. In this story then, it's going to be 50,000 times 10% divided by 12. That's the top answer. I'm going to call that guy 1. And on the bottom, it's going to be 1 plus 10% over 12 raised to the power 10 times 12. 10 times 12. Take away 1. And that I'm going to call 2. Okay, I've done the start. Go for it. Finish it. I think some of you look like you're finished. Hopefully the rest can catch up as we're doing this then. I'm going to go for this top one. 50, 1, 2, 3, 50,000. Yep, times 0.01 divided by 12. I guess I should put the brackets, but it won't matter. Right, anybody want to volunteer the answer before I hit it and see if you got it right? What's the top? Number 1.
You just want me to yell it out?
Yeah, go for it. Yell it out.
Okay, I got 244.09 when I rounded the cent.
You got a 2?
Yep.
Okay, let me try it again. 1, 2, 50.
You accidentally put 0.01.
Oh, and I was careless. And there's what, 416? Is that right?
Yes, same as last, which is weird.
Well, I think the decimal point was shifted, so it looks very similar. So let's try that again. I get 50,000 times 10% divided by 12, and I got this number. Did anybody else get 416 and change?
Yes.
Okay, so I'm
Yes.
going with that one. So that's the top answer. 416 and change. Right, the bottom one.
Oh.
Ugh.
I did the whole problem. Sorry.
Oh, well,
The
Hold
final
that
answer.
thought. Hold that thought.
I did it wrong. I put everything in there. I'm looking at it. It's all right. Okay, never mind. Ignore me. I'm gonna be quiet now.
okay, 0.1, well, not forever. Divided by 12. Raised to the power, well, that's 120. And then I'll take away 1. And it does the 1.707 and change look good? Right, so 1.7070. And then we can check it against your answer now. So it's going to be 416 and 60, lots of 60s, divided by blue button entry, which is the answer. $416.66 divided by blue button answer. $244. What, 8 cents, barring some rounding off. Does that look good, Tara? Was that what you said? Right. So do you feel comfortable that it's a plug and chug question, right? As long as you know you're using this formula and you got all the numbers that you need to know to put into the formula and one guy to find, which is this guy here, you can now do these types of questions. I believe there's, if you work in a bank or a finance company kind of thing, they are very special calculators. I think they're called finance calculators. I'm not saying buy this, probably you shouldn't. They're complicated, but essentially what a finance calculator does is it has all these formulas programmed into it. So all they do is they say, oh, I want a sinking fund formula, and they hit it. And the screen comes up and it says, okay, what's A? You type it in, enter. What's the R? You type it in, enter. So you just type in the information and it does everything and it pops out the answer. So if you're going for a mortgage and you wonder how come she's so, or he, whatever it might be, is so good at telling you how much your mortgage is going to be, they're probably using one of those calculators. You know, they're very specialized, but they're great for this type of thing. Are we good with sinking funds? Do you feel comfortable with them? Okay. Before I finish then, I'm not going to do any more questions if you feel comfortable with them, but I do want to show you, hopefully, what the questions look like, just so you get a feel for what they look like as homework. They're quite cryptic. They don't have a story attached to them, which many of them do. Right. Are you looking at questions?
I don't see them.
Okay, try plan B. Are you looking at questions now?
Yes.
Yes.
Okay, some of you, I don't know why you're not seeing it, but this is what we have here. So if I start at the first question, question 7, can you see they just tell you everything you need to know in a little table and the answer goes up there? And the answer that they're talking about is M. So can you see in this one, it's going to be 80,000. It's semi-annually. Doesn't that mean N equals 2, twice a year? Semi-annually. 3%, 10 years. Another twice a year, there's a quarterly. So N would be 4, exactly. But in every single one of the questions, they really don't have a story worth talking about. They do use the word sinking fund. So if you can somehow, when you write your notes, kind of do sinking fund and formula, and not saying copy what I've got unless that's helpful to you, but have whatever makes sense to you. Have a kind of sinking fund formula and what all the things are, right? And oops, and if you have maybe on the other side, for instance, you know, if you do the little card thing, maybe you could make up a question with all the numbers in it and the, you know, the steps, so that you can look at it and say, oh yeah, you have to do that and get the answer, and then you have to do this and get the answer, and then you divide the two answers, and that's how I could do it on my calculator, you know. I'm not one of them. I have seen students who are really, really good at calculators, and they do the whole thing in one go. Hat off to them. I wouldn't even attempt it. Oh, Tara, stop sticking your thumb up. Show off.
I
Right.
suck at this stuff, but now that I figured out my calculator, because the Mesa Center finally, I emailed them the first day of class when you told us the other calculator because I didn't want to have to go buy another one.
Yeah.
And they finally messaged me yesterday and they're like, oh, we saw your message. And I'm like, yeah, in the meantime, I figured out how to use this one. So if anybody's using one of the TI 36X Pros and need a few ideas, I figured this bad boy out now.
Okay, we now have an expert on the TI. What one is that, Tara?
TI 36X Pro. It's the typical one for the chemistry. For anybody who's doing the nursing program, probably has this one.
Okay,
And it's
so
just a few buttons different, but it's really easy once you figure out what the button is.
right. So similar enough so that the buttons I'm pressed, you could figure out what to do in your machine.
Yeah, they're like the opposite side of it. So it's like the X with the square up above. That's what you need for that exponent. You push that
Okay.
and it gives you the box on the brackets. That was really hard for me to get it to do because it kept wanting to do the other things. And it's the same thing. There's two ways to do like when you're doing the continuous, the PE. To do the E with the power of, you can do it either the long way and get the part. And then log is almost the same. It's just the in log button on this thing. So the buttons are in there. It's just different names. So it gets a little confusing. Go away.
Gotcha. Thank you.
Go work.
If we are finished with sinking funds, can we move on to the next one then? Do you feel comfortable about I've forgotten how many, the 5 questions that you end up doing using that formula? Are we good? Right. I am going to move on to our next one, which is the last one. This is the last finance section. After that, the next topic, you won't nearly be doing your calculator as much, right? It's going to be a lot less stressful as far as calculators go. It'll maybe be stressful in other ways, but a lot less stressful in that way. So just stay signed in. It's amateurization. God, they have some great words on it. Now, I did notice that some people, successfully, even better than that, have already started these questions. It's kind of cool. I want to show you the horrible formula, like the ultimate version of horrible, right? Are you looking at 11.6 amateurization screen?
I don't
Okay.
see it.
I don't know what is. I think my computer's just been a pain in the butt. Somehow or other, it's not detecting my second screen. I wonder why that is. Let me check something at the side here. That's selecting camera. That's not what I want. Okay, I can still get it if I hit that button, right? You seeing it now?
Yes.
Yeah, I used to be able to hit another window I've got called second screen. I have 2 screens there. So if you wonder why sometimes I'm not looking at you, I'm looking at the other screen instead of forwards because I've got a camera up here and I have a different camera here, which is the one I use for my white thing. And I've got a screen over here. So sometimes I feel like I'm watching tennis, you know, don't not carry on. Okay. That is pretty much what the formula from hell. Would you agree? That's pretty ugly, right? It's massively ugly. Then I'm going to write this formula down, and then I'll take you through what each piece of this massively ugly formula is like. So If you bear with me for a few minutes while I write this down, then I'll return to our normal screen. Okay. Come on, there we go. Okay, all the guys that you are used to, and darn it, I gone and missed one. There we go. There we go. M is the payments that you make, typically monthly. R, you know that's going to be the interest rate in decimals. N is going to be number of payments. T is going to be time in years. And P is called the present value. Of an So if you use this formula, it will tell you the present value of an annuity. And essentially what you're going to be doing here is, here's the ugly formula. And they will tell you pretty much all of those guys. And you're going to find him. So let's see what that looks like. On the question that I'm doing right now, which is similar to question number 1, you're paying $50 a month. The interest rate is 5%, which is 0.05. You're doing it monthly, and the time is 4 years. So there's the guys. And we're going to find the future value. No, sorry, the present value. P. So, excuse me. Start again. So we're going to find P, which is called the present value. And it's going to be M, bracket, 1 take away 1 plus R over N to the power of negative NT, all over R over N. This guy is, in my opinion, so ugly that it's better to do it in 3 pieces rather than 2. So the guys I'm going to call piece 1 is nothing. You just write down what M is. It's just like a placeholder, right? Because I just don't want to do it with the other calculation. The second calculation is going to be this guy here.
I have a question.
Yes,
Would you plug in the 50 for M or would you wait?
I would wait. Yeah, I would just wait. And 3 is going to be that guy. Now, in that, oh, I may change my mind. If you said, do you mean just plug in 50 there? Yes, I agree with you. I would do that. Now, R over N, which is just this fella here, the guy I'm calling number 3, isn't too bad. What is it? 0.05 divided by 12. And so I'm putting him in as 0.0041 in lots of sixes. And the one that's really the troublesome one, to be honest, is this thing here. So I'm now going to try and do this guy, number 2. 1 takeaway bracket. 1 plus the interest rate divided by 12 raised to the power of negative 12 times 4. Watch what I do in this calculator here. 1, pretty easy. Subtract, start a bracket, nothing too surprising. 1 plus 0.05 divided by 12, close the brackets, raised to the power. This is the weird one. Do you notice that says negative 12 times 5? Do not hit subtraction button. This guy down at the bottom, the one in white that's got little brackets around it, that's the negative button. It looks just like the subtract, but if you hit that button, you'll just get an error and wonder what you've done wrong. You hit this button down here, that's the tricky part. Now, I'm doing that in my head because it's easy, 48. Now, when I hit enter on this guy, I'm going to get 0.1809 and some stuff, right? So I now can do the whole kit and caboodle. P is M, which is number 1, times this ugly guy, number 2, divided by number 3. So 1 is M, 2 is this guy, and 3 is this guy. So I can just go to my calculator now, and I can say 50 times the answer to 2, which is 0.180928, and then just divide it by 0.0041 lots of sixes. And then I'll hit the answer, and the answer I now have is 2171.14. So $2,171.14. Now, that might seem a lot long-winded to you, but I'm trying to reduce my chances of screwing up. And for me, smaller chunks I can do without screwing up. It's when I try and do too much in one go that I tend to lose the place. The hardest one is definitely this guy here, right? Number 2 is going to be the one that's going to be the challenge. I don't think 1 is trivial and 3 is pretty trivial. But separating that guy out and then going 1 times 2 divided by 3. Oh, you got it. Do you like the look of that question? I'm sure I'm going to show you more. You want to see more anyway, don't you? You got to see this happen at least 2
Yes,
or 3.
please. I think I got it though. After the last complicated sinking thing, this one doesn't seem so scary.
Well, yeah, by the time you get used to them, they'll have finished and there won't be any more of them to do. So this one is going to be similar to question 2. In this question, oh no, that 2 is too like 3. I'm not doing 2. It's so question 2 is just like question 3, right? This is 3. The M is 150, so you're putting away 150. You're getting an interest rate of 8%. You're doing it over 20 years. And you're doing it monthly. And we're going to find what they're calling P, right, the future value. Right, so we've got everything that we need. So it's going to be M. 1 take away this guy.
Is it present value or future value? I thought future value was
You're
A.
right. You're right. You caught it. I screwed up. It's present value. In fact, it's pretty obvious, isn't it? P for present. I should have figured that out. I forgot. There we go. So that's going to be 1. That's going to be 2. And that guy's going to be 3, right? So 1 is $150. That wasn't hard. Right, that was in. 2 is going to be this guy. So that's going to be 1. Take away 1 plus interest rate as a decimal divided by 12. Negative, what's that going to be? Negative 20 times 12. Okay, negative 12 times 20. Right, let's see what that guy looks like. 1, subtract a bracket, 1 plus 0. Raised to the power, negative button, right? Negative button. Oop. 12 times 20 is 240. Just did that in my head. Enter. Number 2 is 7, 0, 2, 8, and 6. The more of these you write, the less chance you'll be 82 cents out at the end. Right, so the more decimals you use, the safer it is. For 3, it's just R over N. And that's 0.08 over 12. 0.08 divided by 12. And I get 0.00, lots and lots of 6s. So to get the future value, 1 times 2 divided by 3. Clear that out of the way. There it goes. 50. So it's on 50 for 1 times that guy there, 0.7970,286 divided by 0.00, lots of 6s. And I get the answer 17,933.15.
Does it matter how many 6s you put? Because if you, I feel like if I put less 6s, then my
You'll
answer
get-
is just a little off.
It will be. Now, I put a 1% tolerance on WebAssign, or at least I told it to do 1%, which means it'll catch that and you'll be fine. But thinking you've done it and WebAssign actually doing it may not be the same. So let's just play on the side of safety, and the more decimal places you use, the fewer times you're going to disagree with WebAssign. Does that make sense? Just hit a lot of buttons. I know it's boring. I totally agree it is. But you have to
So
kind of do it.
what are these problems called on there? Is this the ordinary?
This is
annuity
called
formula?
present. Well, these questions are all the ones we're doing right now. The key sentence is present value of an annuity. So when you see that sentence, you're using this guy. The present value of an annuity.
I found an easier way to do it in a calculator because I'm really bad at transposing numbers.
Well, then you need to do whatever works for you, right? I know that whatever I show is not perfect for everyone. I'm okay with that. My experience has told me that most students find if they try and do it in one big go, you need so many
No, what I
brackets
did was I
inside
took the way
brackets.
that
Sorry?
yeah, what I did is I took the way that you were breaking it down, and
Mhm.
on number 2, when I got to number 2 and I got the number, then I multiplied it by the 150, and my calculator has a divide like a fraction part, so it'll let me do it and divide
okay.
and just fill it in. And it
got it.
actually made it a little bit easier. I have less mistakes
Go for it.
because I did your formula. And then when I got to the very last step, instead of having to put both the sets of numbers in and worried that I didn't get them in right, I used the fraction, the division button on my calculator that puts it like a little fraction.
Okay.
And it worked really good.
Right. The TI-84 doesn't do that, unfortunately, but for yours, yeah. You got to figure out your calculator and your brain. Right. So everybody is going to do what works for them. And I'm totally cool with you doing it that way because you've figured out a way that works and it's good and you're happy with it and you're comfortable with it. You should certainly keep doing it. This works for me. Yeah, this works for me, and it typically it's pretty resilient. It takes longer. Okay, I think it's time we did you try one on your own thing, and then I'll do it, and that'll be a good sign that we are on target. We all know, hopefully, how to do it now. So here goes. Okay, so I need a story with an M in it, an R in it, an N in it, a T in it, and we're going to find P, right? Okay. How much are you willing to pay a month? Give me a number.
200.
Whoa, you're rich. 200 a month. Instead of doing a car payment, you've decided just to hold on to your car until it dies, and the money that would have been a car payment is now going into this fella. Okay. Interest rate, how about 6%? Pretty good. We'll just keep it as monthly.
Do they do
Oh.
it can we do it different from monthly?
Um,
Or you said it's typically monthly?
I'm just going through all the questions just to check that. Every single one that they do is monthly, so let's just do it monthly. You know, you could do other numbers, but let's just stick to, you know, the most likely question, which is that one. How long do you want it for? That could be for anything.
3 years.
I'm going to screw that up. Just a little bit. You're going to just do it for 30 months. Ooh, sneaky. All right, and I'll see if you can figure out how to accommodate 30 months. Because you know 30 months is not the same as 30 years, right? You have to figure out what that does. Okay, go for it. It's hard to judge. 4 minutes, how about that? 4 minutes to get the future value of this annuity.
Do you mean the present value?
There I did it again. The present value of that annuity. I can't get that word future out of my head. The present value of this annuity. Oh, excuse me.
Totally relatable.
Okay, here goes. Got our formula. I'm going to do 1, 2, 3. M is 200, so that was pretty straightforward. 1, take away 1 plus R over N to the power of negative NT. How do we cope with the 30 months? How do we cope with 30 months? Did anybody have a workaround for it?
Make it a decimal.
Okay, so how much would you divide 30 by to make it a decimal number of years?
12.
That's what I would do. And so you get 2.5 years. Now I want to show you something that's kind of sneaky here. 2.5 times 12, right? 12 times 2.5. Do you notice that that adds up to 30? So we're ready to put it into the calculator. It's 1, take away a bracket, 1 plus 0.06 divided by 12, close the brackets, raised to the power of negative 30. So see if that had said 82 months, do you know I could have just put minus 82 here and it would have matched. Right, enter. According to, well, I have 0.13897, some more stuff. So it's going to be 200 times the guy I just mentioned a minute ago. all divided by, oh, I haven't done 3 yet, so I guess I should do it now. 0.06 divided by 12. And that comes out as 2 zeros and a 5. So 0.005. So 200 times 0.138970 divided by 0.005. And I'm looking at 5558 point, I guess 80 cents. So 5,558. Look good? 5,000. Well, 5,500 really. Okay. The questions that we have just finished doing are excuse me, are these guys here, and they end up being questions 1, 2, 3, and 4 of the last homework section, which is 11.6. And you'll recognize those formulas because they mention present value of an annuity. So that's what we've been doing for the last half hour. Our next group of questions, let's show you what they look like. And these are going to be, the key here is that these guys all use a name called the amortization. Now, I'm not an expert at banking and the ins and outs of financing, but evidently this is a formula that they like and use for something. They don't tell you this, so let me tell you what it is. See, if you take this formula here, see if you take this formula here, the one we've been using, you're told M and all this stuff, and your job is to find P. But see if I tell you P and all this stuff, you're going to find M. So this formula is just a rearrangement of that formula. So if you're wondering where it comes from, it's taking a present value formula, but it's turning it on its head. It's saying, okay, I want the present value to be this much. How much money do I need to put away a month? This question says, if I put this amount away a month, how much will my present value be in the future, later on? That's why I keep saying future, I guess. So when I look at this formula, it has all the same pieces that every one of these formula has. P is the present value. R is going to be the interest rate as a decimal. N is going to be the number of payments, which is typically monthly. So it'll be 12. And T is the time in years. Or parts of years. And we are going to be asked to find M, which is the monthly payments. So instead of being told the monthly payments and trying to find the present value, we're being told the present value and we're going to find the monthly payments. And this ugly character is the one that's going to do that. And to try and make your homework a little bit clearer, I'm going to put the numbers that use this guy. 5 and 6. So far, so good. Right, so you know there's going to be a story where they tell us stuff. Basically, they tell us this stuff and ask us to find that guy. So the one I'm going to choose here, question 5. In this case, the present value is 14,000. R is the interest rate. N is 12 because it's monthly, and T is 4 years. So that's what question 4 looks like. And I now know what this is.
Is this what question 4 or 5 looks like?
This is what question 5 looks like. Yes, this is question 5. But I've said I know what this is now. I'm 90% sure I know what this is. There are some investments that you can do which guarantee you a retirement amount. In other words, they guarantee to pay you so much a month. Some of them guarantee to pay it for the rest of your life. So if you live, you know, to your 120, they'll pay it until then. And others pay it back to you over a certain period. And that's what we've got here. So what you're going to get here is you give them $14,000 right up front. They're giving you this interest rate, and monthly, over a period of 4 years, they're going to pay you money, essentially until it's used up. So I wouldn't want to use this to survive on retirement, but you know, you could use this to give to your kid for 4 years at college. Because you know, if you give a kid $14,000 and saying this is for college, what's going to be left of it next month? Oh, you've got great kids. $0. Aren't they going to party or buy a motorbike or do something fun and exciting, but not very good? If you do this, what happens is that they just get a little check, right? It'll be a deposit into their bank of a certain amount every month. So let's see how much, if you put away 14, right? So, oh, you're going to college. I've set up an annuity for you. I put 14,000 with this company for the next, 4 years. Every month, they're going to put a check into your account, and that'll help you, pay for some of your bills. So we got all the good guys. Let's see what that looks like as a real calculation. Knowing the way I approach these questions, how do you think I might split this one up?
Do the top part first and then the bottom.
You're in my head. That's exactly how I'm going to do that. So I'm breaking it up into, my manageable chunk theory, right? So the guy on top is P R over N, which is what? 14,000 times 9% as a decimal divided by 12. Okay, see what that guy looks like. 14,000 times 0.09 divided by 12. Okay, 105. So remarkably nice answer. Normally I expect 0.8233, that kind of carry on. But hey, Nice answers are good. I like it when they happen. Now 2 is going to be this guy. That's going to be 1. Take away a bracket. 1 plus 0.09 divided by 12 to the power of negative 12 times 4. Let's see if I can get that guy. Let's clear that out of the way. 1 take away. Pretty much what you see is what you get. 1 plus 0.09 divided by 12, close the brackets, to the power of negative 12 times 4. I'll do that bit in my head. Negative 48. Enter. That guy ends up being 0.30138858 and some stuff. So you're going to get M, the guy on top divided by the guy underneath. It is going to be 105 divided by 0.3013858. Now, since that is the last thing I typed in, I can do this shortcut, 105 divided by blue button answer. And you are going to be sending your kid $348.39 a month. Hey, might pay for food, right? Better than nothing.
Do you round up the answer? For the
You're into the
39?
nearest whole number, so 39 is what I'm rounding it to. That's the nearest whole number of cents. In a way, couldn't we just write down any old weird formula with R, N, P's and T's, and couldn't you just plug it into your calculator and say, okay, for that formula, this is the answer? And don't get too caught up on the, why is that formula that? Why is there a negative here? What's that doing there? I mean, you could get a headache trying to figure these formulas out. Cleverer people than me have figured out what these formulas are. But it's now within our ability that if you tell me the formula, can I use it to get the answer I want? Okay, I'm going to do another one. That was like 5. I know they jump about a little bit here, but yeah, I want this one. This is like question 6. And I want, I am going to give them $150,000. That's a lot of money. And how could I do that? Well, one way it can be done is, can you imagine that you sell your house and you have some mortgage left on it, but once you've covered the mortgage, you still have 150,000. Now you could just put it in the bank and live off it. And if you did that, you'd just be getting interest, bank interest, which isn't very high, 0.5%, 1%. Or you could go to a financial company and they will make a contractual deal with you. They'll take the 150 from you and they will guarantee you, in this particular story, a phenomenal interest rate in 9%. Really good interest rate. And it's going to be paid monthly. And they're going to give you it for 20 years. So if you figure out, yeah, I'll probably be dead in 20 years, that's not a big deal. Whatever. Or, okay, when it runs out in 20 years, it runs out, whatever way you want to look at it. I wonder how much money they'll give me every month. Because when they do the calculation, they'll say, okay, we promise to pay you every month for the next 20 years, X amount of dollars. Do you think it'll be in the hundreds, or do you think it might be in the thousands, or not even in the hundreds? What do you think 150,000 shared out over a 20-year period might get you? Any gut feelings for that? No. Well, let's find out then. I don't know either. I was just curious in case you might have. I'll have a guess. $700. There's my guess. God, look at the time. 1, 2. $150,000 times 9% over 12. Two. It's going to be this guy. See what that looks like. I'll do one first since it's already set up. 150,000 times 0.09 divided by 12. So this number is 1125. See what this guy is. 1 subtract brackets 1 plus 0.09 divided by 12, close brackets, to the power of negative 240. And the answer I get out of that fella is 0.833587. And they are going to guarantee me that amount a month for the next 20 years. And what does that look like? It looks like 1125 divided by that guy. On my calculator, I can do the 1125 divided by blue button answer. And I was way wrong. They will pay you $1,340, about $1,350 roughly. $1,350 a month for 20 years. Okay, that would pay for your rent, right? You know that for the next 20 years you don't need to buy a house, right? You could just rent somewhere for that kind of money. Your rent's paid. You just need to, you know, utilities, food, fun, that kind of stuff. Maybe you could use your social security money to do that. Maybe you've got other investments. You could maybe work with them. Why do some people do these types of investments? This is typically for someone who doesn't like risk. Technically, there's no real risk to this because what you're doing is you've entered a contract with a company and that company will pay out this money. Now, the only things that could go wrong would be that the company goes bust, right? It just goes bankrupt. And I don't know. I just think that this might be true. I'd have to check it. But I think these kind of investments are protected by the FDIC, right? Which basically means if a bank goes bust, you get your money back, right? This type of investment is probably covered in that. So even if the company goes bust, you're still safe. So it's for someone who is risk averse. They just don't want to risk, the stock exchange crashing or interest rates going down or up or all the other variables. And they just want to say, well, I'm happy. I'll take that for the next 20 years. Here's the money. You do that for me. We're both happy. The way that these companies actually are able to do that is they normally invest your money in something that returns more than 9%. So they might be, they invest it in the stock exchange, or they invest it in property or some other process, and they get it. Any questions about that horrible guy? You comfortable about this formula and what it does? Right, so as always, at least today, as always, we're going to give you your own version to try out then. So how about, keep the numbers relatively nice. You're giving them 100,000. The interest rate that you're going to get is 7%. You're going to do it monthly. And you're going to do it for 15 years. So find him. That's your job. I'll give you 4 minutes to have a shot at that one, then we'll do it together after that. So see if you can find M. Last few things. Okay. Get this show on the road. Top guy, bottom guy. Top guy is 100,000 multiplied by 0.07 divided by 12. So looks like I'm going to be doing 583 with lots of threes. And then 1, take away a bracket, 1 plus 0.07 divided by 12, close the brackets. Don't forget that negative. 12 times 15 is 180. And I'm looking at, wow. That looks big. Did anybody get a number like 182? Okay, I have to trust the math. So it's going to be 583, lots of threes, and 182.
That's not right.
It isn't right.
No.
Okay, let me check that again. 1 takeaway brackets, 1 plus interest rate 0.07 divided by 12, close the brackets, raised to the power of negative 12 times 5. Well, that's 150 plus 30 is 180, so it's not that's screwed up. There we go. I have no idea what the screw up was, but I now have what seems to be a much more reasonable number. So I'm going to go 583 point lots of threes divided by second answer. How does $898.83 look? You can
Right
wiggle
on.
a 95, 90, you know, depends on how many threes you added when you did your calculation. We are getting really well on here, which is good. So what's left to do? Well, there's one last topic, quite a realistic one. Mortgages and loans. How do we calculate? I was looking here, I think I might get it still, like go for it. Oh, darn it in space. I had it and I lost it. I'll get it in a second, I'll show you. We're going to look at the what formula used for mortgages, and you're going to be surprised, I think, because you've actually used it before. So it's down here somewhere. If I keep scanning, I'll find it. Come on, keep going. No, I'll tell you if I can't find it, but it'd be more fun if I find it. Because at least you can go and have a look when you get to doing it. Oh, that's weird. Right, on my last page, it better be here. And I got it just at the end. Right. I'm going to show you the piece of the textbook where it actually goes into this. So Sometimes you're going to do your homework and you're going to say, oh, I've forgotten what formula was going here. Right, find a monthly payment on a house, which is called your mortgage. And do you recognize this fella here? Whoops. Do you recognize this guy here? Isn't it the guy that we've been doing for the last 15, 20 minutes? Right. So that formula can be used to also calculate mortgages. And it's kind of the reverse process of you pay me X amount a month, and it now becomes you pay the bank X amount a month. It's like the bank is you and you're the bank, but the formula stays the same because you're really paying a certain amount and you're going to get something back from it. So let's make up some story and show you. Mortgages are good. I like mortgages. Card loans and all the other ones use the same formula. The only difference is that when you do a card loan, isn't it 4 or 5 years probably? You do a house, it's what, 20, 25, 30 years. When you do a house, it's hundreds of thousands. When you do a car, it's in the tens of thousands. So although the numbers change, the math is going to be exactly the same as the guys that we've been using. So let's suppose you saw the house of your dreams and it cost, that's what you're going to have to pay to buy it, right? You could quibble over the price, but you've quibbled over the price and you got it down to 500,000. In fact, I'm not doing this because it just makes my life and your life horrible. Don't you very often end up buying it for $499,999 because for some reason it doesn't seem quite as expensive, right? And in some situations they actually do that. I think most people now don't fall for that one. Would you agree it's a $500,000 house and that's what it is, right? Now, you've got a good job and you are going to the bank and the bank looks at your credit history and how good you have been in the past about paying rent and utilities and credit cards and everything else, and they give you a credit score and they come out and they say, you are going to get a 4% interest rate. In today's market, that's not a very good interest rate. Do you know you can get, I've seen adverts, I'm not quite sure how truthful they are because the devil is in the detail, but I've seen adverts that are saying you can get 2% now, which is phenomenal. You never got 2%. So if you're going to buy a house, this is the time to do it. There will be strings attached, like it'll cost you, $5,000 to get that rate and, other things. They call it points. But we'll keep it simple. You got a 4% interest rate. You are going to be paying monthly. I don't know of anybody who doesn't pay monthly mortgages, right? That's the way you do it. You do it monthly. So far, so good. Now, how many years are you going to pay your mortgage? Well, 30 years is very common. Does anybody know any of the other common years that mortgages are done with?
15.
Yeah, 15 is very common. I've seen 20s and 25s, but they're less common. Now, we are going to do this question twice. We're going to do it same house, same interest rate, 15 years. So that would be called a 15-year mortgage. Or a 30-year mortgage. So before we even do a calculation, and the calculation we're going to do is, what's my monthly payments, right? What do I pay per month, right, for the mortgage company? Do you think I'll pay the same, more or less for a 30-year? What do you think a 30-year will be compared to a 15-year?
So much more.
In total, but how much per month? If you pay over 30 years, your mortgage is less But because you're paying it over 30 years, the total you pay back is a lot more. You know, if you went and bought a car, even if it wasn't a brand new car, if you pay it off in 3 years and you pay it off in 5 years, don't you pay less money per month for the 5 year, but more money in total because you're paying it for 5 years, not for 3 years? So it's that kind of balance thing. So this is going to be a large monthly payment. It's my prediction, and I know it's going to be true. And this is going to be, I guess I'll call it smaller than this guy, monthly payment. So when you go to the bank, they look at things not just like your credit rating, but they actually look at how much money do you make, how much money does your partner make, and then they, you know, they do some jiggery pokery with the numbers, and they come up with, for you, a 30-year mortgage would work, right? If you try a 15-year mortgage, you might be house poor. House poor just means that you spend so much on your mortgage that you don't have a lot left over to do anything else, right? So here goes, first one. Put it over here, like that. Our monthly payment. Hey, M makes sense now, doesn't it? Monthly payment. Finally have a letter. P, what you paid for the house, so P kind of makes sense. R over N. 1 take away 1 plus R over N minus NT. So P is going to be, I'm changing into English, what you paid for the house. Actually, you don't pay it, don't you borrow the money to pay it, right? So what's your loan, essentially? R is going to be your interest rate, as it always is, as a decimal. N is going to be monthly payments, because that's what you do. And T is going to be a 15-year mortgage. Well, let's see what the monthly payments at 4% look like. Well, you could get oh, getting tired here. Oh, too late now. I'm just rewriting the formula down. I guess that's worthwhile because these are notes. You don't do this every time. But that's going to be 1, right? And that's going to be 2. So 1 is the P R over N. That's 500,000. Interest rate divided by 12. $500, 3,000 times 0.04 divided by 12. And the answer I get here is 1666 and a lot of sixes. I then go for the ugly second guy. One, take away this fellow. 1 take away 1 plus the interest rate over 12, negative 12 times 15. And it's going to be 1. Well, I don't need to do 1 take away, it's all going in the calculator. So 1 take away, bracket around it, 1 plus 0.04 divided by 12, close the brackets, raised to the power of negative, oh, that's 180 payments. And this guy looks to be about 0.4506 and stuff. So my mortgage payment, which is 1 divided by 2 is going to be 1666.666 divided by this guy. I take this fella and I go 1, 6, another 2 6s, 0.6s, divided by 0.45064, and whoa. That is a heavy duty mortgage payment, you agree? You better have a partner whose entire monthly salary is devoted just to that, right? So you need a partner who clears about 50,000 a year, right? And their salary just pays the mortgage, right? And your salary does the rest. But at the end of 15 years, which is not that long, really, in the big scheme of things, you'll own outright a $500,000 house, which has probably grown in that 15-year period to maybe $700,000 house. That's what happens. So that's a good deal, right? If you could handle it, that would be a really good deal. Not many people can, but it's cool. Now, we're going to keep that number handy. And we're going to do a 30-year mortgage. Now, most of what I've got here, all of this is the same, so I'm not going to write it. Is number 1 going to be the same? For a 30-year mortgage, isn't that top the same number? So I don't need to do number 1 again. Number 1 is still going to be that guy. Because it's still 500,000, still the same interest rate, still 12. Now the 2 is going to be where the change happens. So it's going to be 1 take away 1 plus 0.04 divided by 12 to the power of 12 times 30 years. So if I go back to this fella, it's 1 take away, do a bracket, 1 plus 0.04 divided by 12, close the brackets, to the power of negative 360. And this number is 0.69820. So let's find out what the second mortgage is. This, by the way, this is going to be my last calculation of a few things I want to do after this, but I'm not doing a new question. I'm just going to use these. So that ends up being this fella divided by this fella. And the mortgage payment ends up being 1666 point lots of sixes divided by 0.69820 and 238.79 cents. Let's put those together. If you do a 15-year mortgage, your monthly payments will be 3698.44 cents. If you do a 30-year mortgage, you will only be paying that amount, right? Now, superficially, you'd think, why on earth would I do a 15-year mortgage when I can pay the house off using that amount? Well, look again, don't you have to pay it for twice as long? So what I'm going to do now is calculate the total amount that you pay. Now, in a 15-year mortgage, you pay $369,844 a month. You do it for 12 months and you do it for 15 years, right? So by the time you've bought that house, this is how much money you've given back to the bank. 3698 times 12 times 15. And the answer, $665 640. So for a $500,000 loan, you're going to have to give them 665. So it's an extra 165,000, and that's on a 15-year loan. Now going to do the total amount. You pay on a 30-year mortgage. Well, on a 30-year mortgage, you only pay $2,387.09 times 12 months times 30 years. So 2,387.09 times 12 times 30. And that ends up being $859,352.
Can you move up the sheet?
There we go. You see it here?
Ouch.
Yes. Ouch.
That's $193,626 difference.
Yes.
Holy cow.
Can you see that when you are in the business of getting a mortgage, right? So we're going to stay here, and mortgages aren't right for everyone. If you don't have the money to pay it and keep paying it, it's a dangerous thing, because if you stop paying, they foreclose on you, your credit is shot for the next 10 years. You'll probably find it hard to get renters, you know, because people don't like renting people who go bankrupt and so on and so forth. It can really screw up your life. So don't think about buying a house unless you really are in a stable relationship. You've got a job that you're pretty comfortable that you're going to be in, and you know the money you're going to make. But if you can, buying a house is a really good investment. You might think, well, that doesn't look like a really good investment. Well, let's look at the pluses. Don't you get a $500,000 house? In 30 years, how much do you think a $500,000 house is going to be worth? I'll tell you right now, it's going to be worth a lot more than $500,000. It's probably going to be worth $1 million. So you get all your money back, right? And on top of all of that, don't you get 30 years of rent? Right? You're not paying rent.
Brianna.
You're not paying rent. So yeah, it's a very expensive process, but if you can afford it, it's a good thing. Don't get a mortgage if you're only going to be here for 3 years. If you're Navy and you know the guy, or you or whoever it might be, are going to go be somewhere else in 3 or so years, it's not worth it. And because they charge you, finance fees and finder fees and all the. I mean, they nickel and dime you death at the start. So don't do it if you're going to be there 3 years. But if you know you're going to be here for, it doesn't need to be for 30 years. If you know you're going to be here for 10 or 15 years, mortgage is a good way to go. The interest rates right now are ridiculously low, and if you can afford it and it's a wise decision for you, you should seriously look into it and see if it works for you. It's a good way of putting your money to work, because if you pay rent, aren't you paying that guy's mortgage? Because typically a lot of people, when they have a renter, some of them own them, but a lot of them actually just buy the house, pay a mortgage, but your rent is more than the mortgage, so your money is actually paying their mortgage. Just thought I'd put that thought out there. Okay, it's time to say hi.